XQ-58A Valkyrie, History, Present, Future and Impact. Introduction. The XQ-58A Valkyrie is a pioneering step in the evolution of unmanned combat aerial vehicles UCAVs developed by Kratos Defense Security Solutions under the United States Air Force's USAF low-cost Attritable strike demonstrator cast program. This aircraft represents a significant paradigm shift in military aviation, emphasizing cost-effectiveness, operational flexibility, and advanced technology to enhance combat capabilities. History of the XQ-58A Valkyrie. The journey of the XQ-58A began with its first flight on March 5, 2019 at the Yuma Proving Ground in Arizona. Created to act as a loyal wingman for manned aircraft, the Valkyrie was designed to perform various missions including reconnaissance, electronic warfare, and offensive operations. The aircraft's development was motivated by the need to provide a low-cost attritable option to support high-value manned platforms, particularly in contested environments. The Valkyrie project is part of the USAF's broader initiative to integrate unmanned systems with manned platforms, as evidenced by the Skyborg program, which aims to create autonomous systems that can work alongside traditional aircraft. The XQ-58A was initially designated the XQ-222, but it was renamed to reflect its operational role and capabilities. Design and development. The Valkyrie is designed with a focus on affordability and technology. Each unit costs approximately $2 million, making it a fraction of the price of traditional manned combat aircraft such as the F-35, which can exceed $85 million. The design features a sleek, stealthy profile with a trapezoidal fuselage V-tail and an S-shaped air intake, enhancing its radar-evading capabilities. One of the most notable aspects of the XQ-58A is its ability to operate in swarms, controlled via encrypted data links from a parent aircraft. This capability allows for sophisticated tactics that can overwhelm enemy defenses. The Valkyrie can be launched using various methods including rocket boosters, trolley systems, and conventional takeoff and landing CTOL methods, providing flexibility in operational deployment. Operational history. Following its inaugural flight, the XQ-58A underwent extensive testing to evaluate its performance and capabilities. On July 23, 2020, the USAF awarded contracts to several companies including Kratos for the Skyborg program, with the Valkyrie being a key player in this initiative. By March 2021, the Valkyrie successfully demonstrated the ability to open its internal weapons bay and launch a small drone, showcasing its multi-role capabilities. In December 2022, the U.S. Marine Corps ordered 2 Valkyries for its PAACK-P program, with testing commencing in October 2023. The U.S. Navy also expressed interest in variants of the Valkyrie, highlighting its potential applications across different branches of the military. Future developments. Kratos is actively working on multiple variants of the Valkyrie, including the MQ-58B, which is tailored for electronic warfare and suppression of enemy air defenses. Reports indicate that a CTOL version with landing gear is also under development, which could enhance the Valkyrie's operational capabilities and allow for traditional runway operations. These new variants are expected to feature underwing hardpoints for munitions, further expanding the Valkyrie's combat potential. The flexibility of the Valkyrie design positions it well for future military needs, particularly as the landscape of modern warfare continues to evolve. Impact on warfare. The introduction of the XQ-58A Valkyrie signifies a critical shift in military strategy. The trend is moving toward a model where fewer, more expensive manned aircraft are supported by a greater number of low-cost drones. This strategy aims to reduce risks to pilots and high-value assets while enhancing overall combat effectiveness through autonomous systems. The Valkyrie represents the USAF's response to emerging threats from advanced adversaries, particularly in contested environments where modern missile systems pose significant risks to air superiority. By leveraging low-cost attritable platforms, the Valkyrie enhances the USAF's capability to maintain air dominance and adapt to the complexities of modern warfare. Conclusion. The XQ-58A Valkyrie is set to fundamentally alter the dynamics of air combat. Its combination of affordability, advanced technology, and operational flexibility positions it as a vital asset for the USAF and other military branches. As testing progresses and the Valkyrie moves closer to full operational status, its integration into military operations is likely to redefine tactical approaches to air warfare in the coming years. The Valkyrie's capabilities as a loyal wingman combined with its low production costs will enable military leaders to adopt more aggressive strategies in contested environments, ultimately enhancing the United States' ability to project power and maintain strategic advantages in future conflicts. As the landscape of warfare continues to evolve, the XQ-58A Valkyrie stands at the forefront of a new era in military aviation. XQ-58A Valkyrie, the history, present, future, and impact. History. The XQ-58A Valkyrie is an unmanned combat aerial vehicle UCAV developed by Kratos Defense Security Solutions as part of the USAF's low-cost Attritable strike demonstrator cast program. Its first flight occurred on March 5, 2019 at Yuma Proving Ground, Arizona. The Valkyrie was developed in response to rising threats from advanced adversaries, particularly Russia and China, and aims to provide tactical advantages in contested environments where modern missile systems threaten air superiority. The Valkyrie was initially designated as the XQ-222 and was designed to function as a loyal wingman for manned aircraft. This concept allows it to perform tasks such as reconnaissance, defensive fire, and even absorb enemy attacks, thus protecting more expensive manned aircraft. Its development aligns with the USAF's strategic shift towards integrating unmanned systems into conventional combat operations. The design of the XQ-58A emphasizes low production costs, with each unit estimated to cost around $2 million, a stark contrast to the F-35, which costs approximately $85 million. The Valkyrie's affordability facilitates the potential for fielding a larger number of drones, thus enabling new tactical approaches to air combat. Present. As of 2025, the Valkyrie continues to undergo flight testing and development. The USAF Skyborg program, initiated in 2020, aims to integrate unmanned systems with manned platforms. The Valkyrie has demonstrated its capabilities through several test flights, including launching a small drone from its internal weapons bay in March 2021. The U.S. Marine Corps has also shown interest, ordering 2 units for testing under the PAACK-P program in December 2022, with operational testing commencing in October 2023. Kratos is actively developing multiple variants of the Valkyrie, including the MQ-58B, which is designed for electronic warfare and suppression of enemy air defenses. This variant will enhance its operational capabilities alongside other platforms such as the F-35. The ability to launch from conventional runways is being explored as well, with a new version featuring landing gear under development, which could increase the Valkyrie's versatility. Future. Looking ahead, the XQ-58A is poised to become a fundamental component of future U.S. military operations. The integration of autonomous systems into combat scenarios raises questions about the nature of warfare itself. The Valkyrie's ability to operate in swarms, execute complex missions autonomously, and support manned aircraft suggests a shift in military strategy towards a model that prioritizes lower-cost attritable assets. The ongoing development of the MQ-58B indicates a move towards specialized roles within the drone system, focusing on electronic warfare capabilities. The introduction of landing gear for conventional operations could further broaden its operational scope, allowing for higher sortie rates and more flexible deployment options. Impact on warfare. The XQ-58A Valkyrie represents a significant paradigm shift in air combat and military strategy. Its design as a low-cost, high-capability drone aligns with the USAF's goal of maintaining air superiority while minimizing risks to pilots and expensive manned aircraft. The transition from a few high-cost airframes to a larger fleet of low-cost drones echoes historical shifts in military strategy reminiscent of tactics seen in World War II. The Valkyrie's ability to absorb losses and operate in high-risk environments could redefine how air campaigns are conducted, particularly against advanced enemy air defense systems. The use of autonomous wingman drones allows for more aggressive tactics, potentially overwhelming enemy defenses by deploying multiple units simultaneously. However, the integration of autonomous systems raises ethical questions concerning decision-making in combat scenarios. The potential for drones to operate independently may lead to concerns about accountability and the moral implications of autonomous warfare. Critics argue that reliance on AI-driven systems could lead to a detachment from the human elements of warfare, resulting in a more reckless approach to combat. Counterintuitive insights. 1. Cost-effectiveness versus high technology. While many assume that advanced military technology necessarily comes at a high price, the XQ-58A demonstrates that cutting-edge capabilities can be achieved through cost-effective designs. The Valkyrie's production cost of approximately $2 million challenges the notion that more capable systems must be prohibitively expensive. 2. Autonomy and human oversight. The idea that autonomous systems might reduce the risks to human pilots could be seen as paradoxical. While the droning technology reduces human casualties, it simultaneously introduces concerns about moral and ethical implications of AI in warfare. This reflects a tension between technological advancement and the preservation of human oversight in lethal decision-making. 3. Swarming tactics. Traditional military strategies often emphasize the deployment of fewer high-value assets. The Valkyrie's development as a swarm-capable platform suggests a counterintuitive shift back toward quantity, albeit with low-cost drones that can operate in conjunction with manned aircraft. This represents a potential reversion to strategies that favor overwhelming force through numbers rather than solely relying on sophisticated technology. 4. Integration of variants. The development of specialized variants like the XQ-58B for electronic warfare challenges the conventional wisdom that UAVs should remain generalized platforms. Instead, the Valkyrie's evolution indicates that diversification within drone capabilities could be more beneficial than a one-size-fits-all approach, allowing for tailored solutions to specific tactical challenges. 5. Perception of risk. The Valkyrie's cost-effectiveness may lead to a perception of drones as expendable assets, influencing commanders to take greater risks with their deployment. This could lead to a re-evaluation of risk management in military operations, where the loss of an aircraft is weighed differently against the potential for mission success compared to traditional manned systems. In conclusion, the XQ-58A Valkyrie is not just a technological advancement, it is a harbinger of a new era in air warfare. Its ability to operate as a cost-effective, versatile platform capable of autonomous operations could redefine military strategies and tactics in the face of evolving global threats. The implications of its deployment extend beyond mere combat effectiveness, prompting critical discussions about the future of warfare ethics and the role of human agency in military operations. Important content overlooked in the XQ-58A Valkyrie report. When examining the XQ-58A Valkyrie and its implications for modern warfare, several aspects may not receive the attention they deserve despite their significance for military strategy, operational effectiveness, and ethical considerations. 1. Cost efficiency and scalability. Significance. The reported production cost of the XQ-58A, approximately $2 million per unit, is a key factor that facilitates the U.S. Air Force's shift towards a loyal wingman strategy. This cost is significantly lower than that of advanced manned aircraft such as the F-35. The affordability allows for the potential production of hundreds of units annually, which can lead to a paradigm shift in how air combat operations are conducted. Overlooked aspect: the scalability of deploying these drones in swarms may not be fully appreciated. While the Valkyrie is designed to operate alongside manned aircraft, the ability to deploy multiple drones at once can create overwhelming force against adversaries, compensating for the reduced numbers of manned aircraft. This operational flexibility can alter engagement strategies, enabling a more aggressive posture against well-defended targets. 2. Integration with manned systems. Significance. The Valkyrie's role as an interoperable component in existing air operations is crucial. It is not merely a standalone system but is designed to augment the capabilities of manned fighters like the F-35 and F-22, enhancing their effectiveness in contested environments. Overlooked aspect. The complexity involved in integrating the Valkyrie with manned systems, particularly in terms of communication and data sharing, may be underestimated. The reliance on encrypted data links to facilitate this integration raises questions about cybersecurity and the potential for electronic warfare tactics to disrupt operations. As adversaries develop countermeasures, the robustness of these communication systems will become increasingly significant. 3. Evolving tactical concepts. Significance. The introduction of the Valkyrie signifies a shift in tactical concepts from traditional air combat to a more networked multi-domain approach. The ability to operate in swarms and autonomously perform tasks such as scouting, reconnaissance, and even offensive maneuvers may redefine air combat strategies. Overlooked aspect. The implications of this shift extend beyond mere tactics. They influence how military training and operational planning are structured. As military leaders begin to plan for engagements involving swarms of drones, there will be a need for new doctrines that encompass the employment of autonomous systems, including tactics for both offensive and defensive engagements in complex environments. 4. Ethical and moral considerations. Significance. The introduction of autonomous systems like the Valkyrie raises profound ethical questions regarding the use of AI in combat. The notion of machines making life-and-death decisions even if under human oversight challenges existing military ethics and rules of engagement. Overlooked aspect. Discussions surrounding the ethical implications of autonomous warfare often focus on the potential for loss of human oversight. However, the moral hazard of risk compensation, where pilots might take greater risks due to the expendable nature of drones, also deserves attention. This psychological shift could lead to more aggressive tactics that prioritize mission success over pilot safety, potentially increasing the likelihood of civilian casualties and collateral damage. 5. Long-term strategic impact. Significance. The development of platforms like the Valkyrie could signal a new era of warfare where lower cost, attritable systems dominate the battlefield. This shift may reduce the reliance on expensive manned aircraft while allowing for more versatile and adaptable military responses. Overlooked aspect. The long-term strategic impact also includes the potential for arms races in drone technology. As the U.S. develops and deploys these systems, adversaries are likely to respond with their own autonomous systems, leading to a proliferation of drone warfare capabilities. The implications for global security and international military balance are profound and warrant further analysis. 6. Variants and future developments. Significance. The anticipation of multiple variants such as the XQ-58B for electronic warfare and the CTOL version for traditional runway operations underscores the adaptability of the Valkyrie platform. Each variant's specific capabilities will allow for tailored applications across different military branches and missions. Overlooked aspect. The broader integration of these variants into joint operations among the Air Force, Navy, and Marine Corps could foster inter-service collaboration and interoperability, which are often challenging due to differing operational cultures and priorities. The success of this integration will hinge on comprehensive inter-service training and joint exercises that emphasize coordinated use of these platforms. 7. Global geopolitical implications. Significance. The Valkyrie's development is not isolated to U.S. military strategy. It reflects broader geopolitical shifts, particularly in response to the rising capabilities of adversaries like China and Russia. By enhancing its drone fleet, the U.S. aims to deter potential aggression and maintain air superiority in contested environments. Overlooked aspect. The global arms race implications of such technologies may not be fully recognized. As other nations seek to develop similar or counter technologies, the resulting competition could escalate tensions and lead to new military doctrines that prioritize drone warfare. The U.S. must navigate these geopolitical landscapes carefully, balancing technological advancement with diplomatic engagement to prevent miscalculations and conflicts. Conclusion: the XQ-58A Valkyrie represents more than just an advancement in unmanned aerial vehicles. It signifies a transformative shift in military strategy, operational concepts, and ethical considerations in warfare. Recognizing and analyzing the overlooked aspects of its development and integration into military operations is critical for understanding its potential impact on future conflicts and global security dynamics. As the military landscape continues to evolve, the Valkyrie may well be a harbinger of the future of warfare. Key points for in-depth analysis and discussion on the XQ-58A Valkyrie. 1. Innovative design and cost-effectiveness. The XQ-58A Valkyrie is engineered to provide a low-cost alternative to traditional manned combat aircraft. With a production cost of approximately $2 million per unit, it is significantly less expensive than advanced fighters like the F-35, which costs around $85 million. This affordability allows for mass production, with Kratos Defense estimating the potential to manufacture between 250 to 500 units annually. The design features stealth capabilities, various launch methods including rocket and trolley launches, and the ability to conduct missions autonomously or under the control of manned aircraft. This innovative design not only enhances operational flexibility but also addresses the increasing need for cost-effective solutions in modern warfare. 2. Operational role as a loyal wingman. The Valkyrie's primary operational role is to serve as a loyal wingman to manned aircraft. It can perform various tasks such as reconnaissance, electronic warfare, and even offensive operations by carrying weapons in its internal bay. The integration of Valkyries with manned fighters allows for enhanced situational awareness and combat capabilities. The drone can absorb enemy fire, thereby reducing risks to pilots and high-value assets. This shift towards unmanned systems in combat reflects a significant change in military strategy, emphasizing the need for adaptability in contested environments, particularly against technologically advanced adversaries like Russia and China. 3. Future developments and variants. As the program progresses, multiple variants of the Valkyrie are being developed to meet different operational requirements. For instance, the MQ-58B variant is tailored for electronic warfare and is intended to suppress enemy air defenses while operating alongside F-35s. Additionally, a version equipped with landing gear is under development to enable conventional takeoff and landing, thereby increasing sortie rates and operational flexibility. These advancements suggest that the XQ-58A will continue to evolve, enhancing its role in future military operations and potentially redefining engagement strategies in air combat. 4. Ethical and strategic implications of autonomous systems. The introduction of the XQ-58A and similar autonomous systems raises important ethical and strategic discussions. While the U.S. Air Force emphasizes that human operators will retain control over lethal decisions, the increasing autonomy of drones like the Valkyrie sparks concerns about accountability in combat situations and the potential for unintended consequences. As military operations increasingly rely on AI and autonomous systems, there is a pressing need to build trust in these technologies among military leadership, as well as to address moral dilemmas associated with their use. The outcome of these discussions will significantly influence the future landscape of warfare and the role of humans in military decision-making. Conclusion. The XQ-58A Valkyrie represents a transformative approach to modern air combat, combining innovative technology with strategic foresight. Its development not only highlights the shift towards unmanned systems in warfare but also provokes critical discussions about the future of military engagement and the ethical considerations of autonomous weapons. As testing continues and the Valkyrie moves closer to operational status, its impact on military strategy and air superiority will become increasingly apparent. Famous historical cases similar to the XQ-58A Valkyrie. 1. Northrop Grumman B-2 Spirit stealth bomber. The Northrop Grumman B-2 Spirit is a strategic bomber that was developed during the Cold War as a response to the need for a stealthy aircraft capable of penetrating dense anti-aircraft defenses. Its first flight was in 1989 and it became operational in 1997. The B-2 was designed to carry both conventional and nuclear weapons and is known for its unique flying wing design, which helps reduce its radar cross-section significantly. The B-2 introduced stealth technology in a way that changed strategic bombing approaches, allowing for deep penetration into enemy territory without being detected. Similarly, the XQ-58A Valkyrie leverages advanced technologies to provide a low-cost stealthy option for modern warfare, enabling the U.S. military to adapt to new combat environments and threats. 2. MQ-1 Predator Unmanned Aerial Vehicle. The MQ-1 Predator was one of the earliest unmanned aerial vehicles used by the United States military for both reconnaissance and targeted strikes. Deployed in the late 1990s, the Predator became a symbol of modern warfare, showcasing the effectiveness of unmanned systems in combat. Its ability to provide real-time intelligence and conduct precision strikes revolutionized military operations. The XQ-58A Valkyrie follows in the footsteps of the Predator by extending the concept of unmanned systems not just for surveillance but also for offensive missions, and doing so at a fraction of the cost of manned aircraft. The Predator's influence on military strategy and tactics echoes in the Valkyrie's design as a loyal wingman that can operate alongside manned fighters. 3. F-117 Nighthawk Stealth Fighter. The Lockheed F-117 Nighthawk is often regarded as the world's first operational stealth aircraft, developed in the 1970s and first flying in 1981. It gained fame during the Gulf War in 1991 when its ability to evade radar led to successful bombing missions against high-value targets. The F-117's design principles, focusing on radar-absorbing materials and unique shapes, paved the way for future stealth aircraft, including the B-2 and the current generation of fifth-generation fighters like the F-35. The XQ-58A Valkyrie incorporates similar stealth technologies, aiming to provide a cost-effective solution for modern air combat while complementing existing manned aircraft capabilities. The operational success of the F-117 demonstrates the potential impact of stealth technology on military strategy, which the Valkyrie seeks to emulate in a new era of warfare. These historical cases highlight the evolution of military aviation and the strategic shifts that accompany technological advancements, mirroring the trajectory of the XQ-58A Valkyrie in its mission to redefine air combat dynamics. Future outlook. Predictions for the XQ-58A Valkyrie. The XQ-58A Valkyrie is set to redefine air combat dynamics and military strategy over the next decade. As it transitions from experimental phases to operational deployments, several key predictions can be made regarding its future impact, technological advancements, and strategic applications. 1. Increased integration with manned platforms. The XQ-58A will increasingly serve as a loyal wingman for manned aircraft, effectively enhancing the operational capabilities of platforms like the F-35 and F-22. Future air combat operations will likely see Valkyries deployed in swarms alongside piloted fighters, allowing for coordinated missions that leverage the strengths of both manned and unmanned systems. This integration will not only improve situational awareness and combat effectiveness but also reduce the risk to human pilots in high-threat environments. 2. Expansion of operational roles. As development progresses, the Valkyrie is expected to expand its operational roles beyond reconnaissance and strike missions. Future variants such as the MQ-58B will focus on electronic warfare, suppression of enemy air defenses (SAD), and potentially even cyber operations. This versatility will allow the Valkyrie to adapt to various mission profiles, making it an indispensable asset in modern warfare. 3. Cost-effective attrition strategy. One of the Valkyrie's key advantages is its low production cost of approximately $2 million per unit. As military conflicts evolve, the U.S. Air Force will likely adopt a strategy that emphasizes a higher quantity of attritable assets. This approach allows for greater risk-taking in combat scenarios, as losing an XQ-58A will be less impactful than losing a high-value manned aircraft. The ability to deploy multiple Valkyries will provide the U.S. military with a significant tactical edge, especially in contested environments. 4. Advancements in autonomous operations. The Valkyrie's future will also be shaped by advancements in artificial intelligence and autonomous systems. As the Skyborg program evolves, the Valkyrie will likely incorporate more sophisticated AI capabilities, enabling it to perform complex missions autonomously. This could include real-time data processing and decision-making, allowing the drone to react dynamically to changing battlefield conditions without direct human intervention. 5. Enhancements in launch and recovery systems. Future iterations of the Valkyrie, particularly those equipped with conventional takeoff and landing CTOL capabilities, will facilitate greater operational flexibility. This will enable the Valkyrie to integrate seamlessly with existing Air Force infrastructure, including traditional runways and aircraft carriers. Enhanced launch and recovery systems will lead to increased sortie rates and operational availability, further solidifying the Valkyrie's role in modern air combat. 6. Global adoption and export potential. As the XQ-58A proves its effectiveness, there will be growing interest from allied nations in acquiring similar drone technologies. The U.S. could leverage the Valkyrie's proven design as a template for international partnerships, potentially leading to foreign military sales. This could establish a global ecosystem of compatible unmanned systems, enhancing allied interoperability in joint operations. 7. Ethical and regulatory challenges. As the Valkyrie and similar autonomous systems become more prevalent, ethical concerns surrounding their use will intensify. Debates about the role of AI in lethal decision-making will prompt military leaders and policymakers to establish new guidelines and regulations governing autonomous warfare. The U.S. military will likely need to navigate these challenges carefully to maintain public trust while capitalizing on the operational advantages of unmanned technologies. 8. Impact on military strategy and doctrine. The integration of systems like the XQ-58A will fundamentally alter military strategy and doctrine. Traditional combat paradigms that prioritize high-cost, low-quantity manned platforms will shift towards a model emphasizing affordability, attrition, and rapid deployment of drone swarms. This transition will require military leaders to rethink tactics, training, and resource allocation in response to the changing nature of warfare. Conclusion. In summary, the XQ-58A Valkyrie is poised to have a profound impact on the future of military aviation and combat strategy. With its combination of cost-effectiveness, versatility, and advanced technology, the Valkyrie will enhance the U.S. military's capabilities in contested environments while also prompting significant changes in how wars are fought. As it evolves and integrates into operational frameworks, the Valkyrie will undoubtedly play a crucial role in shaping the future of air combat and military strategy worldwide.